This simulation is going to allow you to collect the data for the specific heat of a solid lab. Because it is a Adobe Flash, you may not have access to it. So I am going to kind of work through the simulation, allow you to record the data that you see, and then you can work it up in the lab reports. So notice that we've got a bunch of different samples. We're going to test 4 knowns, 2 unknowns. We can control the mass and the starting temperature of the metal. We control the mass and the starting temperature of the water here. Over here, we identify what metal we're going to use, what the specific heat of the metal is if we know the metal. So if I go to silver, you can see we actually have a specific heat here. If we have an unknown, it's going to be your task to figure it out. So there is no number in there. This is where the final temperature will be recorded. So the final temperature is going to be the final temperature of both the solid and the water. So the water is going to heat up, the solid is going to cool down until it reaches the common temperature point. So let's get started with the data. So I just kind of picked some arbitrary information just so that you can see the relationship between the temperature change and the specific heat. We're going to do 1 sample of each, silver, gold, copper, and iron. I'm going to do 20 grams. I tried to do 150 and I can't seem to get it set there. So 149 is the best I can do for getting the sample there. So you want to make sure that you record the actual data. Can I get it to 149 again? There we go. So we're using silver, 20 grams of it, starting off at 149 degrees. We're going to keep the mass of water at 30 and room temperature is about 20, so that's good. So then we are just going to hit start, and you're going to see the sample dropped in to the calorimeter. So what you're seeing, here's the temperature probe. Here's the spinner to kind of keep the water moving so that the temperature stays consistent. That little cube is our sample, and you can see the very light blue water. And so then this whole chamber is our calorimeter. So the assumption is all the energy that the metal is losing is going into the water, and we're picking up that temperature change with the thermometer. So reaction is done, and take a look at the number. The final temperature of the system is 26.64. It's kind of what we're sitting on. So for silver, 150 degree or 149 degrees, 20 grams. The temperature change, the final temp was 24.6. Now it's fluctuating again. What did I say? 6.4. We'll set it on 6.4. Okay, so we're going to do the same thing with gold. It happens pretty fast, so we're going to collect all this data pretty rapidly. The slow point is me getting it to 149 grams. I'm tempted to just keep it 148. Okay, so now we have gold. See the pretty gold color. So we're going to do the same thing. We're going to start by dropping the sample into the water. The temperatures and the masses are listed to the left. Now we're watching as the water heats up and the metal cools down until it equilibrates to the same temperature. And it doesn't take long for this. You can see the reaction is done when the little spinner stops moving. So we're at 22.56. Okay. So we'll reset again. We'll go to copper and take it up to 149. Oh, there's 150. How did I manage that? Oh, now it's not letting me. Okay, we're going to stick to 150. Okay, so copper at 150. So make sure you take note of what the temperatures are. First two were 149. This one's 150. It's not going to make a difference when we calculate the delta H because the temperature change will be proportional. So we'll drop the copper in to our water. Watch what happens. I really don't like that the graph is right here in the middle of everything. I would like it off to the side. Focusing on the temperature change of the water. going up a little bit higher than the last two. Okay, so we're peaking at 27.54525452. Let's stick with, we'll stick with 5.2. We'll stick with 5.2. Okay, next up is iron. Take it back up to 150 or 149. Okay, 149, I got it. Drop the iron sample in. And this one is going up by a lot as well, just like the copper did. Sometimes I don't know what to say as we're watching the data get formed. 28.6. 28.6, let's sit on 6.7. Okay, 28.67. Now to the metals. We're going to do a couple different pieces of data collection for the metals so that you guys have a chance to collect or to calculate the delta H with a couple different sets of data. So these aren't really trials because I'm changing the variables. But we'll start with what we did before with sample X. We'll go up to 150 or 148. Okay, 148. Metal X, notice that we have no specific heat because we don't know what the metal is. So that's your purpose of this lab. You're trying to find what the specific heat is. So we'll drop the metal in the water. Notice nothing has changed other than what the metal is in the starting temp. And so the temperature is climbing kind of fast, kind of steep. So based upon the data you had before, what does that tell you? Is that a big specific heat or a little specific heat? So we're going to stop that at 29.60. Okay, now I'm going to do still 20 grams, but we're going to change the starting temp. We're going to lower it a little bit, take it to 100 degrees. Okay, so 20 grams, but now starting temp is 100 degrees. We're still doing metal X. So let's see what temperature we can get for the final in this one. There's our little spinner, keeping the water consistent. Temperature's going up nicely. I feel like we should be playing the Jeopardy song. So there we have hit 26.0, 26.01. Okay, that's 100 grams, 100 degrees Celsius for 20 grams of sample X. Now I'm going to change the mass. So we're going to stick with, or we're going to go with 50 grams of the sample. I'm going back up to 100 and, what did I do before? 149, 150, whatever it was, 148. Okay, so we're changing the mass. We'll see what the final temp is for that one. So then this will be the last of the three pieces of data that we get for metal X. And then we'll go on to metal Y and we'll do the same kind of thing. So when you calculate the specific heat from each of these three tests, you'll average the specific heat at the end to see what we get for the sample. All right, so we've got a temperature of 41.62 for the final, 41.62 for the final. Okay, so those are three sets of data for metal X. Hopefully you wrote that all down. Let's move on to metal Y. We'll go back to what we did all of the knowns for, 20 grams and 149 degrees Celsius. Again, we don't know what the specific heat is. That's what our job is to find out. Start the reaction, start collecting the data. Let's see what happens to the sample. So we've plateaued out at 29.18. Okay, back to metal Y. We're going back to 20 grams, 20 grams, but 100 degrees Celsius. Metal Y is picked. Okay, let's see what happens here. Complete silence. Just watching that line go. Kind of mesmerizing. All right, it's plateaued at 25.68. And then our last piece of data, we're going to do 50 grams at back up to the 150 degree mark. We actually got it to 150. Okay, so sample Y, 50 grams of it, 150 degrees Celsius. That's our last piece of data. Let's start that and see what happens. We're almost done. All right, what's our final temp? 40.8. 40.88. Okay, we'll stick with that. So hopefully you have collected all the data. You should have 4, 5, 6, 7, 8, 9, 10 pieces of data. The first 4, there's really no calculations to do, the silver, gold, the copper, and the iron. You've seen all the data. We know that what the specific heat is. That's really just going to let you see how temperature changes with specific heat. But X and Y are going to allow you to calculate the specific heat of each sample and ultimately identify what it is. Okay, good luck.